We can subtract the sum of I2 and I1 by 6.25.
Yes, well done. That we can write it like the total current in the circuit. We can write it as IT, which means that this is the total current, which we are finding out. IT. I can use the brackets for T. Total current is equals to I1 plus I2 plus I3. Done. Now total current is, you tell me what is the total current? 6.
It is 6.25.
Well done. It is 6.25. What is I1?
2.5.
No problem. Good. 2.5. What is I2?
1.25.
1.25. And what is I3? Question mark. Now what we are going to do, we are going to make I3 identical. We are going to move 2.5 and 1.25 on the other hand side, and they are going to be subtracted there. So 6.25 minus 2.5, and then again minus 1.25, which is equals to I3. Fine. Now what does the answer calculate? 6.25 minus 2.5 minus 1.25.
2.5.
Okay, let me try as well. 6.25 minus 2.5 minus 1.25, we got 2.5. Good. So I3 is equals to 2.5 amperes. Done. Sorry. Fine. Now, let me drag it here. And let me change the color as well. So it is clear for you. Okay. Now this is the value of I3. Now we have the voltage here. We have the current I3 here. Can we find out the resistance? How?
R is equal to V over I, so 30 divided by 2.5.
Yes, R3 is equals to V over voltage over I3. Voltage is 30. The current is 2.5. Do the calculations. 30 divided by 2.5.
12.
Let me do the calculations as well. 30 divided by 2.5. 30 divided by 2.5. It is no. 30 divided by 2.5. It is 12. Yes, good. And what will be the unit?
Ohms.
Yes, ohms. Okay. Now what else do we have to find here? Let's look at the question. We have to find I2. We are done with it. We have to find RT, total resistance. Okay. We know the other circuit is parallel. Which formula we are going to use?
1 over RT is equal to 1 over R1 plus 1 over R2.
Yes.
1 over R3.
Yes. Good. So we are going to use 1 over RT is equals to 1 over R1 plus 1 over R2 we have the values of all the resistance here. So we just have to substitute the values here. Fine. So let's do it. Let's copy paste it. Okay. 1 over what is the value of R1?
12.
1 over 12 plus what is the value of R2?
24.
Yes. What is the value of R3?
12.
Yes, 12. Okay. Let's do the calculations. 1 over 12 is equals to
0.03, 0.083.
I guess let's take the LCM and solve it. What do you say? Because we prefer
Yeah,
students to take LCM rather than to write the answer in points. Fine.
yeah, that's
So
what I
what will
do.
be the LCM of 12 and 24? Let's take it out.
24.
Yes, it is 24. 12 and 24. 20, 12 times 1 is 12, and then 2, and then 2 here, so it is 24. Okay. So it is 24, and then 12 times 2 is 24. 24 times 1 is 24, and then 12 times 2 is 24. Now we are going to multiply 2 by 1. We will get 2, plus we are going to multiply 1 by 1 here, and then again we are going to get 2 here. So RT is 5 over 24, which is equals to,
24 over 5.
yes, because RT is in the denominator, we are going to do the cross multiplication. So RT will go here and 24 will go here. So it is 24 over 5, which is equals to RT. Okay, solve it. Divide 24 by 25. Sorry, 24 by 5.
4.8.
4.8. Very good. So RT, the total resistance that we got is 4.8 ohms. Fine.
Yeah.
Next. Okay, let's see what else we have to find. I too done total voltage. Let's calculate now total voltage.
It's 30 because all of them are 30.
Yes, voltage is 30 as the circuit is 12. So total voltage VT is equals to 30. Here we can write it that V total is equals to 30 volt. Done. Okay, what else? I2 is calculated, VT is calculated, RT is calculated, R3 is done. Now we have to find the power P1. What is the formula to find out the power P?
I times V.
I times V.
Yeah.
Okay, let's apply it. Power is equals to I times V. But we have to find P1, power at the resistance 1 here. We have to find P1.
Yeah, so
Hmm.
2.5 times 30.
2.5 times 30. Okay, but the formula which I use to calculate the power 1 is V square divided by R1.
I think there's more ways to do it. There's also P is equal to I squared times R. That also gives you the same answer.
The same answer. So let's use it. P is equals to, let's use two methods and we'll check if we'll get the correct answer or not. Fine. So P1 is equals to V square over R1. Voltage square of voltage divided by R1. What is the voltage? Voltage is 30. We
75.
will take the square of 30 divided by R1, which is 12.
You get 75.
Okay, the square of 30 is
900.
divided by 12. It's
75.
75. Okay, the power will be 75 here. Okay, let's apply the other method which you told was P is equals to I into V.
Mm-hmm.
The current here is 2.5. I1 is 2.5. The voltage here is 30. So let's multiply 2.5 by 30. Will we get the same answer?
Yeah.
75. Yes, it's correct. Now, what is the third formula? P is equals to
I squared times R.
I square times R. Okay. So it is P1. So we are going to use I1 and R1. Fine. So I1 here is 2.5
Yeah.
and R1 is
12.
12. Okay. Square of 2.5,
It's 6.25.
multiply by 2.5. Yes, 6.25 multiplied by 12,
Is
75. So all the three formulas are correct. Prefer using this one. This is the simplest one. But it happens sometimes that we don't have the value of I or we don't have the value of voltage. So to ignore that, if we don't have the value of current, we can use why we have three formulas for this to calculate the power, because sometimes it happened in a question that we don't have the value of I. So we can use this one because in this formula, we can calculate the power by V square over R. We don't need I here. We don't need the current. Fine. If we don't have the voltage, we can use this one. P is equals to I square over R. And if we don't have the resistance and we have to find the power, we can use this one. But in this question, the condition was different. We had all the three values. So it depends. We can choose any one of it and we can use the other one to check whether the formula or the answer was correct or not. Is it clear?
Yes.
Okay, so only this was the question which you like wanted me to explain you. You got the
Yeah.
concept? Any confusion?
In some other questions where there are like series, like and parallel components to it, that's where I get confused, like which formulas to use.
They are the complex circuits. So first you resolve it as a one resistance. Fine. You resolve it as a one resistance, like first solve all the series one and have one resistance in the place of all the series circuits, then solve all the parallel circuits, resistance, make it a one, then see what is the relationship between the final and the final two resistance, solve them, and then you will get the answer. You can send me the screenshot of that question. I'll explain it to you tomorrow
Okay.
at the same time.
Okay.
You got this question? The concepts are clear. So whenever you get a question like this in which you have parallel resistance and one voltage, so whenever the resistance are parallel, keep this in your mind that the voltage is equal. Fine.
Mm-hmm.
And total resistance in a parallel circuit is 1 over RT, which is equals to 1 over R1 plus 1 over R2 and 1 over R3. Like this, you can find out the total resistance in the circuit, flowing in the circuit. Same is for current as well. Total current is always equal to all the current which is uh, like flowing through all the resistance here. You can send me the screenshot tomorrow. I'm like, inshallah, I'll explain you the other questions as well. I'll come up with the easier method. The loop method is a little difficult for the students to use.
Okay.
Okay, then take care.
Okay, thank you so much.
Welcome. Bye bye. Take care. Allah Hafiz.
Okay, so the class is done.
Yes, Miss Saba, I'm done with the question.
Okay, inshallah. So tomorrow you can solve some other questions.
Yes, she was asking like for the complex circuits. So you can send me the screenshots and then I'll explain the questions to her tomorrow at the same time.
Okay, but I have tomorrow's Monday, right? So I have summer school until 1:30. So that's when it ends.
Okay, Miss, you can decide the timings with Miss Saba. I'll be available, inshallah. Whatever the time is convenient for you, you can discuss it with with your principal, and then I'll be available at that time.
Okay.
Okay, inshallah. So because it will be night for you, so we'll try to come early, like between 2 or 3 o'clock our time, because right now it's 1:30. So yours is around 11 o'clock or 12 o'clock?
It's 10:30 in Pakistan.
It's 10:30. Okay, inshallah. So in the afternoon, our afternoon and your night.
Yes. Yes.
Inshallah, sister. Okay. Jazakallah khair. Inshallah, talk to you tomorrow. Assalamu alaikum wa rahmatullahi wa barakatuh.
Welcome.